So in this geometry review video, I'll be going over area, volume, sectors, circumference, and density. Feel free to skip around and use the timestamps to pace yourself. So let's start off with the area of polygons. The area of a rectangle is length times width. The area of a square is also length times width, but you can also do side squared. For a triangle, the area is 1/2 times base times height. And for a trapezoid, the area is equal to 1/2 times base 1 plus base 2 times height. So for a trapezoid, it'll look something like this. So if this was a trapezoid, this is base 1 and then this is base 2. So you have to add the lengths of these two bases and then multiply by 1/2 and by the height, which is this right here. This is the height. And for a triangle, say this is the triangle, the base would be here and then this would be the height. But for a right triangle, this would be the height already because it's perpendicular, right? And then this is the base. Okay. So moving on to surface area. Surface area is the total area of all the surfaces of a 3D object. So to find the surface area of all prisms and pyramids, which are made up of polygons, we want to find the area of each face and then add them together. Okay, so for cylinders, to find the surface area, you want to find the area of the two circles and add the lateral area. So basically what I mean is, here's the cylinder, right? This is what a cylinder looks like. If I deconstruct the cylinder, it flattens out into two circles and also this rectangular section right here. So this rectangular section is known as the lateral area, and on your reference table it tells you that the area for the lateral area of a cylinder is equal to this equation right here. So what you want to do is just find the area of these two circles right here and then add it to the lateral area right here, which you can find using, again, this equation. For cones, you need to find the area of the base circle and then add the lateral area. The lateral area for the cone is different from the cylinder and is also given on your reference table and is this equation right here. Okay, just to help you visualize, I'm going to draw a cone right here. And then I'm going to draw a deconstructed cone, which consists of one circle, which is the base circle, and then the lateral area, which is this triangle with the curved bottom. So to find the lateral area, we need the slant height and also the radius. So the radius is right here, is the halfway. And on the cone, it looks something like this. And also the slant height, which is this right here. So here, this is represented by an L. And the slant height is different from the height because the height of the cone is this right here. So to find the surface area, you just want to find the area of this circle and then the area of this lateral area and add it up together. Oh yeah, something that's not on your reference table is the area of a circle, which is equal to pi r squared. You might want to memorize this equation as it is not on your reference table. And one last thing to go over is the surface area of a sphere, which is given on your reference table, and it is equal to 4 times pi times r squared. Moving on to volume. Volume is the amount of space a 3D shape takes up. For rectangle and square prisms, the volume is equal to length times width times height, or base times height. The base for this equation is equal to length times width. But keep in mind that the bases for different types of 3D shapes are all calculated differently because all their bases are different shapes. So, like, for example, a cylinder, right here. On the reference table, it has base. But base in this situation is not length times width, right? Because the base for a cylinder is a circle. So the base right here is going to be 2 pi r squared. So the base for a cylinder is going to be equal to the area of a circle, which is pi r squared. And then again, let's say a pyramid, right? A pyramid looks something like this. It's a really bad drawing. But the base is not a circle, so it's not the same as a cylinder. It's a square, right? So the base for this pyramid is going to be length times width. So really all these 3D shapes, they all have different bases, so you just want to remember they're not all the same equation. B is just a way to shorten the equation, but it doesn't always represent the same equation. Okay, so let's apply everything we went over from the last 3 slides onto these 3D shapes. Okay, so for this rectangular prism, let's try to find the surface area first. Remember that for these type of prisms, all you need to do is just find the area of each side and then add it up together. So in total, you should have like 6 areas added up together, and then you get the surface area. So let's find the area of this side first. The area of that side is equal to 6 cm times 4 cm, which is 24 cm squared. And then the area of this side right here is 4 cm times 3 cm, which is 12 centimeters squared. And then this side is 6 centimeters times 3 centimeters, which is 18 centimeters squared. Okay, so to find the total surface area, you want to do 24 plus 24. We're doing this twice because, see, there's one side right here, and then there's another side that has the same area right here. Okay, there's 6 sides in total. You want to do 12 plus 12, and then 18 plus 18, and that equals 108 centimeters squared. So that's the surface area right here. And then let's go over volume really quickly. Volume of a rectangular prism is just base times height, which is also length times width times height in this situation. Oh my god. So the volume is going to be equal to length, which is 6 centimeters, times the width, which is 3 centimeters, times the height, which is 4 centimeters. The volume comes out to be 72 centimeters cubed. Okay, you always want to remember to like include the units and stuff. Okay, let's move on to this pyramid right here. Let's just say that this right here is 4, this right here is also 4, and this length right here, let's say it's like 8. Okay, so to find the surface area, let's find the area of one side first. This side, okay, is going to be equal to 1/2 times base times height, since, you know, it's a triangle. So the base is 4, let's just say it's centimeters. It's going to be 4 centimeters, and then the height is 8 centimeters. So the area is going to be equal to 16 centimeters squared. Since we know that this is like a square, right, we can just do 16 times 4 to find like the area of all the triangle sides. And then the base right here, the area of that is just going to be equal to length times width, which is equal to 4 times 4. Is 16 centimeters squared. So we just do that plus 16 centimeters squared again, and we get 80 centimeters squared as the total surface area. I'm not going to go over volume for this one, since, I mean, the volume formula is already on your reference table. You can just refer to that. Okay, so to find the surface area of this prism right here, we just find the area of this triangle. And we know the area of a triangle is 1/2 base times height. And then we have to add that by 2 because there's 2 of them. To find the 3 other sides of this prism, we just use the area of a rectangle and add it by 3. So you should have 5 areas in total, and after you add them up together, you get the surface area. For a sphere, let's just say, okay, so for this sphere, let's say the radius is 3 cm, right? To find the surface area, it's given on the reference table that the surface area of a sphere is equal to 4 pi times r squared. So we just need to plug it in, right? 4 pi times 3 cm squared. So the exact value of the surface area would be around 36 pi centimeters squared. Okay, and then the volume of a sphere is also given on your reference table. It is equal to 4/3 times pi times r cubed. So it is going to be times 3 cubed. The volume, I'm going to do absolute again. So 12 pi centimeters cubed. Remember, to find the surface area of this, we need to find the surface area of this circle and then this lateral area. We know that the area of a circle, just give it a radius, right? Let's say the radius is 4. And let's say the slant height is equal to 6 centimeters. Okay, so first let's find the area of the circle. The area of a circle is equal to pi r squared, which is equal to pi times 4 squared. And I'm just going to do absolute. Area is equal to 16 pi centimeters squared. And then for the lateral area, according to the reference table, we know that it is equal to pi r times the slant height, which is going to be equal to pi times 4 times the slant height, which is 6. So the lateral area is going to be 24 pi centimeters squared. Now all we need to do is just add it. So 16 pi times 24 pi is equal to 40 pi centimeters squared. Okay. So the volume of a cylinder is really simple. It's just base times height. But remember, the base is not equal to length times width, unlike the, let's say, this pyramid we had here, right? The base of this cylinder is going to be equal to the area of a circle. So it's just going to be pi r squared times height. Or you can think of it is we just take the base and then we stack it up together until it reaches 9 cm to create the cylinder. The volume is going to be equal to pi times r squared, which is 4 squared, times the height, which is 9, and the volume is going to come out to be 144 pi centimeters cubed. And then for the surface area, I'm just not go over this, but you just find the area of these two circles and then the lateral area, which again is on your reference table and is equal to 2 times pi times the radius times height. So just add all three of those things together and you can get the surface area. Okay, next up we have polygons in the coordinate plane. For these type of questions, make sure you know the distance formula. You can find the side lengths of a polygon on a graph using 2 of its coordinates and plugging it into the distance formula. Remember that this formula is not on your reference table, so you might want to memorize it. So here I have 2 practice questions. Number 1 says triangle ABC has vertices at A is 3, 0, B is 9, negative 5, and C 7, negative 8. Find the length of AC in simplest radical form. So we want to find the length of AC. Okay, so all we need to do is just plug the coordinates of these 2 points into the distance formula. So distance is equal to x1 and x2. It doesn't matter like which one you assign to be 1 or 2. So I'm just do 3 minus 7 squared plus y1 would be 0 minus negative 8 squared. Okay, so we get that the distance is equal to radical 80, but the question asks for simplest radical form. So you can still simplify that into 16 times 5, which is equal to 4 radical 5. Let's do AC is equal to 4 radical 5. That's our answer. Rhombus star has vertices S, negative 1, 2, T, 2, 3, A, 3, 0, and R, 0, negative 1. What is the perimeter of rhombus star? To find the perimeter, right, we have to add the distances of all 4 sides. But we know that in a rhombus, all 4 sides are congruent to each other. Distance, we just plug it into the distance formula. Okay, so the distance of ST comes out to be radical 10. Since we're finding the perimeter, it has to be 4 times radical 10, right? So the answer is equal to 4. The circumference of a circle is the distance around a circle. It is equal to 2 r pi, or the diameter times pi. The diameter is equal to 2 times the radius. So this diagram right here can help you better visualize what is what. And as you can see, the diameter is crossing right here from one side to the other, and then the radius is only half. Okay, so I have 2 questions here. You can try them on your own, or I'll just go over them. A designer needs to create perfectly circular necklaces. The necklaces each need to have a radius of 10 centimeters. What is the largest number of necklaces can be made from 1,000 centimeters of wire? We're given the radius. Let's just find the circumference of one circle. Okay, so we're trying to find how many necklaces we can make with this amount of wire. First, let's just find the circumference of one necklace. So we're given the radius, right? We can find the circumference by using 2 times pi times radius. Okay, so the circumference is around 62.83 centimeters. All we need to do is just do 1,000 divided by 62.83, which gives us 15.9. Okay, so the largest number of necklaces we can make is 15. 0.91 is not able to make a full necklace, so it can't be 16. A circle with a radius of 5 was divided into 24 congruent sectors. The sectors were then rearranged as shown in the diagram below. To the nearest integer, the value of x is... Okay, so the radius is 5, right? So we know that this is 5. And as you can see, the circumference of this circle was split in half here, right? So it's been split in half like this. So x is equal to just 1/2 of the circumference. Circumference of the circle is equal to 2 times pi times the radius, which is 5. So, which is equal to around 31.41. And then if we divide it by 2, we can get the value of x. So 31.41 divided by 2 is equal to 15.70, and it says to round to the nearest integer, right? So it'll be 16. So the answer is 2. Okay, let's move on to the composition of polygons and circles. Okay, so a playground in a local community consists of a rectangle and 2 semicircles, as shown in the diagram below. Which expression represents the amount of fencing in yards that would be needed to completely enclose the playground? So first, perimeter of these 2 semicircles. You know that these can form together into one whole circle, and the diameter would be 15 yards. The perimeter of a circle is basically the circumference, which we know is diameter pi. So circumference is equal to 15 pi yards. And then we need to find these 2 side lengths right here, not the whole perimeter of the rectangle, because again, we're trying to find like the fencing for this whole playground, which we know the 2 of them are 25 yards. So we just do 15 pi plus 25 plus 25. It's equal to 15 pi plus 50. And you have the answer choices. Number 1 is your answer. Okay, a garden is in the shape of an isosceles trapezoid and a semicircle, as shown in the diagram below. A fence will be put around the perimeter of the entire garden. Which expression represents the length of fencing in meters that will be needed? So again, let's start off with this semicircle right here. We know that the diameter is 12. Circumference is equal to the diameter times pi, which is 12 pi. So since this is a semicircle and not a full circle, we have to do the circumference divided by 2. So 12 pi divided by 2 is equal to 6 pi. Adding all the other perimeters up, it says that these 2 are congruent, so 7 centimeters as well. So to find the perimeter, we just do 6 pi plus 8 plus 7 plus 7, which is equal to 6 pi plus 22. So looking at the answer choices, number 1 is your answer. Okay, now we have in the diagram below, math is a rectangle, GB is 4.6, MH is 6, and HT is 15. What is the area of polygon MBATH? So that is just the shaded polygon. First, let's find the area of this big rectangle right here. And we know the area is equal to length times width. So area is equal to 15 times 6, which is equal to 90. Now we just need to find the area of this triangle right here. So the area of a triangle is equal to 1/2 base times height. It's equal to 1/2. The base is also going to be 15 because a rectangle, the sides are congruent to each other. 15 times the height, which is 4.6. Area of a triangle is equal to 34.5. And all we need to do to find the shaded part is just do the whole rectangle minus the triangle part. So 90 minus 34.5 is equal to 55.5. So again, the answer choices, number 2 is your answer. Okay, so moving on to arc length and sectors. The arc length is the distance along the curved line that makes up the arc. So this equation right here is associated with arc lengths. Theta is the central angle, so looking at this diagram right here, this is what theta is. And then the radius is this length right here. So looking at this practice question, Kathy and Tammy are at point A on a circular track that has a radius of 150 feet, as shown in the diagram. They run counterclockwise along the track from A to S, a distance of 247 feet. Find to the nearest degree the measure of minor arc AS. And to find this right here, it tells us that the distance from A to S is 247 feet. To find the angle, know that arc length is equal to theta over 360 times 2 pi r. So we're given that the arc length is 247. We'll do 247 and then theta over 360. And we're also given the radius. So you just plug that in. Now we just want to solve for theta. So 247. Okay, so the answer comes out to be 94.34. So we need to find to the nearest degree. To the nearest degree, the degree would be 94. Theta is equal to 94 degrees. So a circle has a radius of 4.5. What is the measure of the central angle that intercepts an arc whose length is 6.2 to the nearest degree? So again, we're looking for the theta. The arc length is 6.2. And we know that the radius is 4.5. So now we just need to solve for theta. Okay, so it says that we have to find to the nearest degree. So to the nearest degree, this is going to be 79. So number 4 is the answer. Leanna buys a large circular pizza that is divided into 8 equal slices. She measures along the outer edge of a crust from one piece and finds it to be 5.5 inches. What is the diameter of the pizza to the nearest inch? So we have a whole pizza right here, and we know that the arc length for one slice is 5.5 inches. And then we also want to find the diameter. We're given that it is split into 8 equal slices. So this theta right here, theta is going to be equal to 360 divided by 8, which is equal to 45. So again, using the equation, we know that the arc length is 5.5, theta is 45. We're going to be trying to find the radius. So times 2 times pi times radius. So I'm just solve for the radius real quick. Okay, so the radius is equal to around 2.002. And since we're trying to find the diameter, right? We know that the diameter is equal to 2 times the radius. So you have to do 7.002 times 2. So that is equal to 14. So number 1 is the answer. Lastly, let's just go over density. Density is the relationship between mass of an object and how much space it takes up. The equation is equal to mass over volume. The way I like to remember it is the density is equal to a heart, because it kind of looks like a heart. Okay, so it just kind of looks like that. That's just how I remember it. The density of the American white oak tree is 752 kilograms per cubic meter. If the trunk of an American white oak tree has a circumference of 4.5 meters and a height of 8 meters, what is the approximate number of kilograms of the trunk? So we're given that we have a trunk, right? And the circumference of the base is 4.5 meters. And then the height is 8 meters. And we're also given the density right here. So what we're trying to find is the mass, right? We're trying to find the mass. Okay, so first we can find the volume of the trunk. So volume of a cylinder is equal to base times height, which is equal to pi times r squared times height. And we don't have the radius, but we do have the circumference. And we know that the circumference is equal to 2 times pi times the radius. So 4.5 is equal to 2 pi radius. And the radius comes out to be around 0.716. So plugging that into the volume equation, you know that volume is equal to pi times 0.716 squared times the height, which you know is 8. Okay, so the volume is around 12.89 meters. Since we know that density is equal to mass over volume, we're given that density is 752 kilograms, and we're trying to find the mass, and we know that the volume is around 12.89. So we can just multiply these two values together to get m. So the mass is approximately 9,694, which makes number 2 the answer.